Welcome. Today we discuss another part, that is fourth part of theory of quadratic equation for IIT JEE exam. Few problems will be discussed today. The first problem is, if alpha beta are roots of px square plus qx plus r is equal to 0 and PQR are in AP and 1 by alpha plus 1 by beta is equal to 4. Then find numerical value of alpha minus beta mod of alpha minus beta. Its numerical value we have to calculate. Options are root 13 by 9, 2 root 13 by 9, 2 root 13 by 3 and root 13 by 3. So these are the four options. So actually we have to find out numerical value of this. So it must be independent of alpha, beta, p, q, r, etc. So given that these are the roots of that, therefore alpha plus beta is equal to minus q by p, alpha beta is equal to r by p. So these are given from this equation. So once again, PQR are in AP, that is P plus R is equal to 2Q. Moreover, 1 by alpha plus 1 by beta is equal to 4. So from there we get alpha plus beta is equal to minus Q by P, alpha beta is equal to R by P. That's okay. Now max, I calculate first alpha minus beta whole square. Its mod value is, so we actually positive value of this whole square root of this whole square. It is equal to alpha plus beta whole square minus 4 alpha beta. Alpha plus beta whole square minus 4 alpha beta is equal to q square by p square minus 4 r by p. So we have to eliminate, okay, p, q and r. It is a function of q by p. This is another function of q, r by p. So q by p, r by p to be eliminated. Now from from this 1 dividing by p plus r by p is equal to 2q by p. So we get one relation between r by p and q by p. From this relation, alpha plus beta is equal to 4 alpha beta. That is, alpha plus beta is equal to q by p is equal to 4 r by p. Now, from these two relations, suppose this is 1 and this is 2. Two equations involving two unknown. One is q by p, other is r by p. Very easily we can do that. From 1 we get 1 plus r by p is equal to 2 into q by p. Q by p is equal to this one, 4 r by p, 8 r by p. Taking this into that side, alpha plus beta is a minus 4 alpha beta, that is, this is minus. That, just 1 minute. Alpha plus beta is equal to from where? Alpha plus beta is equal to, where I get it? Alpha plus, just 1 minute. This is 1 and alpha plus beta is equal to 4 alpha beta. It is, I get it from there. Alpha plus beta is equal to 4 alpha beta. Okay. Then q by p, alpha plus beta is minus q by p, is equal to, this should be minus, is equal to uh, 4 into minus y r by p alpha beta minus this is equal to this. 4 alpha beta means sub r by p. From 1 and 2, 1 plus r by p is equal to 2 q by p is equal to 2 into q by p is equal to minus of that. That's okay. Then it is equal to minus of that. Therefore, taking this into this side, so 9 r by p is equal to 9 r by p is equal to minus 1. So r by p is equal to minus 1 by 9 and q by p will be equal to minus q by p, that will be equal to minus q by p will be equal, minus q by p is equal to 4 into r by p and r by p is another 1 by 9. Then minus q by p is 4 into r by p means negative. So this is negative. So q by p, we get q by p is equal to 1 by 9. We get 1 by 9. Just 1 minute. Just 1 minute. So minus q by p is equal to 4 into r by p. R by p is here minus that. So this is equal to minus 4 by r by p is equal to plus 4 by 9. So we get these two results. And we have to calculate that so that I rub it so that alpha minus beta whole square, alpha minus beta whole square is equal to q square by p square, 16 by 81. It is q square by p square means 16 by 81 minus 4 r by p plus 4 by 9, so that it is equal to 16 plus 36 divided by 81 is equal to 552 by 81. Hence, mod of that is equal to mod of this, positive square root of that is root over of 52 whole divided by 9. It is 4, so 2 into root 13 divided by 9. So this option is correct. Then next problem. হবে আর কি করা যাবে। Solution of x is equal to 1 plus 1 by 3 plus 1 by 2 plus 1 by 3 plus 1 by 2 up to infinite terms. We have to solve it. There are infinite number of terms. It is simply a simple continued fraction. You see, 1 upon 3 plus that, 1 upon 3 plus that. Actually, this is repeating. 1 upon 3 plus this, actually 1 upon 3 plus 1 by 2, same thing. So it is equal to 1 plus 1 by 3 plus 1 by 2 plus this 2 is that 2. Now it is 1 upon 3 plus 1 by 2 plus infinity. So it is actually this whole thing. So it is equal to x minus 1. So that it is equal to 1 plus 1 by 3 plus 1 by x plus 1. It is equal to 1 plus, this numerator will be there, x plus 1 divided by 3x plus 3 plus 3x plus 4. So that 1 upon 3 plus 3x plus 3, 3x plus 4, x plus 1 is there. So it is equal to 3x plus 4 plus x plus 1 divided by 3x plus 4. And in left hand side it is 1. Left hand side is 1. Hence, we get 3x square plus 4x is equal to 4x plus 5. That is 3x square is equal to 5. So x is equal to root plus minus root over of 5 by 3. But you see, all these terms are positive. So no question that x will be negative. So our answer is plus 5 by 3 root over. Oh, options are not given. So this is our answer. Acha, next problem. A, B, C are real. A, B, C real such that x square plus 2x plus 3 is equal to 0. Oh, sorry. This problem already done. In last video, we did it. If one root is nth power of other root of ax square plus bx plus c is equal to 0, then the value of a to the power n c to the power 1 by n plus 1 plus a c to the power n whole to the power 1 upon n plus 1 plus b. What is the numerical value of that? Options are not numerical. What is the value of that? The options are a to the power n, b to the power n, a to the power n plus b to the power n, 1 and 0. These are the options. अच्छा, तो suppose its roots are alpha and alpha to the power n. One root is nth power of the other root. So this is that. Therefore, we get alpha plus alpha to the power n is equal to minus b by a, and alpha into alpha to the power n is equal to c by a. Now, from there, find value of alpha and we shall put it there. Alpha to the power n plus 1 is equal to c by a. Therefore, it is c by a whole to the power 1 by n plus 1. Now, putting values here, c by a whole to the power 1 by n plus 1 plus c by a whole to the power n by n plus 1 is equal to minus b by a. Multiply both sides with by a. A c by a to the power 1 upon n plus 1 plus a c by a whole to the power n by n plus 1 is equal to plus b is equal to 0. So it is actually, I collect power of a from there and from there also. It is a to the power 1 by n plus 1, a to the power 1 by n plus 1 into a means plus 1 into c to the power 1 by n plus 1 plus here a to the power 1 plus n by n plus 1 into c to the power n by n plus 1 plus b is equal to 0. So it is a to the power this is minus, this is in denominator, everything I have mistaking bar. Acha, a to the power, it is 1 minus 1 by n plus 1 into c to the power 1 by n plus 1 plus this one also be negative. So this is negative. A to the power n plus 1 minus n. So 1 upon n plus 1 into c to the power n by n plus 1 plus b is equal to 0. So a to the power, you see, it is a to the power n plus 1 minus 1. So a to the power n by n plus 1, n by n plus 1 into c to the power 1 upon n plus 1 plus this is a into c to the power n whole to the power 1 by n plus 1 plus b is equal to 0. Now, combining these two, it is equal to a to the power n into c to the power 1 whole to the power 1 upon n plus 1 plus a into c to the power n whole to the power 1 upon n plus 1 plus b is equal to 0. So I think this is our answer. We have to find out the value of that, and this is simply equal to 0. So answer is this, 0. Our next problem. if for all x, x square plus 2x minus 11 by x minus 3 assumes all real values which do not lie between a and b, then values of the pair a and b equal to options 12 4 means a হচ্ছে 12 b 4 then minus 12 4 then minus 12 minus 4 and 4 12. So let us see what is the problem. Given this x is real and it is given that for all real values of x, this expression does not lie between this expression does not lie between a and b. Then what is a and what is b? This is the problem. Let us take that this is equal to y. By cross multiplication, y into x minus 3 is equal to x square plus 2x minus 11. That is x square plus 2 minus y into x plus 3y minus 11 is equal to 0. Now, I can say that it is a quadratic in x, and given that x is real, so that quadratic equation, its roots are x, so its roots are real, therefore its discriminant must be positive. That is, we get 2 minus y whole square b square minus 4 into 1 into that 3y minus 11 must be positive or equal to 0. That is 4 plus y square minus 4y minus 12y plus 44 is greater than 0. That is y square minus 16y plus 48 is greater than 0. We can factorize it. 4 into 4 and 12. তাহলে y minus 12 into y minus 4 okay is greater than 0. So value of y is that. So its value should be such that that product is positive. They lie in 4 and 12. If value of y is greater than 12 means after that this is positive, so this is positive. Okay. If y does not lie, if value of y is below 4, then it is negative, so it is as a whole positive. So y cannot lie between 4 and 12. Between 4 and 12 what would happen? Say 5, it is negative, this is positive, so it will not be positive. In that case, we can say now that y cannot lie between 4 and 12. Cannot lie. So question is, if this value, that is y, cannot lie between 4a and b, then value of a and b. Value of a is this, b is that. So option 4 is correct. My next problem. If The next problem is if x square plus x plus a is equal to 0 and x square plus ax plus 1 is equal to 0 have a common root, then number of values of a, it means these two have a common root, it is given, and then in that case if these two equations have a common root, then number of value of a 2 or 4 or something like that, we have to find number of values of a. So options are no value, second option is exactly 1, number 2 exactly 2, exactly 3. So these two equations have a common root. When 1x is common for this and that, subtracting we get cancels x square 1 minus a into x plus a minus 1 is equal to 0. So we get x is equal to 1, means this is actually in that side 1 minus a, this is 1 minus a, provided a not is equal to 1. তাহলে a cannot be equal to 1. If x is equal to 1 is a root, but this root common, then it must satisfy this, must satisfy that. That is, we get 1 plus a is equal to 0. From there, we get a is equal to minus 2. Value of a is minus 2. So we get one value of a. And it also satisfies this. That is 1 plus a plus 1 is equal to 2. From there, a again minus 2, that is same value. For this value of a, this is a common root. But 1 is a common root, it is 1 is a common root. So it satisfies only one value of a, that is our answer is exactly one value. Next problem. If alpha plus root beta and alpha minus root beta are roots of x square plus px plus q is equal to 0, x, then alpha, beta, pq are all real. Alpha, beta, pq are all real. Then the roots of this equation x square, sorry, not x square, p square minus 4q into p square x square plus 4px minus 16q is equal to 0. Options are 1 by alpha plus minus 1 by beta. Then next option 1 by alpha plus minus 1 by root beta. Third option 1 by root alpha plus minus 1 by root beta. Fourth option 1 by alpha, 1 by alpha, 1 by root alpha plus minus 1 by beta. These are the options. So, one thing, its roots are given in option, its roots are given in terms of alpha and beta only, not in terms of PQ. So from there, from this equation, P and Q have to be eliminated in terms of alpha and beta. Now from this equation of that, its roots are this. Sum of the roots is 2 alpha is equal to minus P. Product of the roots alpha square minus beta is equal to Q. So P square minus 4Q is equal to P square is 4 alpha square minus 4Q, 4 alpha square plus beta. Oh, Mago. Is equal to beta. P square, P is 2 alpha and 4P, Q, etc. are all known. So equation become this equation P square, just I write it down once again, P square x square plus 4px minus 16q is equal to 0. P square minus 4q is equal to beta. P square x square, P square is 4 alpha square x square plus 4px. 4px, is it px? Okay, is it px? So it is minus 4, that is 8 alpha into beta, then eta 4p is this into x minus 16q, 16 minus 16 into q is this alpha square minus beta is equal to 0. That is 4 beta alpha square x square minus 8 alpha beta x minus 16 alpha square plus 16 beta is equal to 0. So now we get roots are in terms of alpha beta. Coefficients are in terms of alpha beta. 4 can be cancelled from there. That 4 beta not cancel. So beta alpha square x square minus 2 alpha beta x minus 4 alpha square plus 4 beta is equal to 0. Now by solving this with respect in terms of Sridhar-Acharya method, we can obtain the value of x, this one. This part you have to simply solve. So by solving Sridhar-Acharya method, this equation by Sridhar-Acharya method, we will get these two roots. Okay, thank you. Thank you for today.